Good afternoon, everybody. Welcome to the Sustainable Futures seminar series, the October edition. My name is Andrew Wolfel. I am the challenge lead for Net Zero in Sustainable Futures. I'm happy to chair the session today. We've got two great speakers. Coming up, we've got Dr. Preece, but first of all, we've got Professor Aoife Foley. Professor Foley is the chair in Net Zero here at University of Manchester, and she's also the managing executive editor and editor-in-chief of Renewable and Sustainable Energy Reviews, the journal. So she's very knowledgeable on all things energy, and I'm happy to introduce her. Today, she's going to be talking about perspectives on sustainability, politics, society, and finance within STEM. Over to you, Aoife.
2 seconds now. Can you see my screen?
We can, yeah. Perfect.
So good afternoon, everybody, and thanks for coming. Thanks for your kind words, Andrew. You're too kind. So I'm actually just 2 seconds now. I'm going to give a talk really on my perspectives on sustainability, how this all links into politics, society, and finance within sort of the greater or the umbrella of STEM. I'm going to talk about my own research, then I'm going to talk about the journal, then I'm going to give my perspectives on, I suppose, this net zero transition, and then I'm going to talk about an initiative I've started up at the moment. It's called the Environment and Energy Education for Today and Tomorrow. And then we can have a few questions and a little bit of a discussion. So every time there's a break between the topics that I'm talking about, you will see the honeybee, and I love bees, and I'm very superstitious, and that was probably one of the things why I came to Manchester, was because when I arrived and I looked it up, the first thing that hit me was its symbol is a bee, and bees, they're revered in most religions or in most cultures. The honey from the bee has fierce healing properties, and they all have to work together to achieve their ultimate goal. And of course, then you have the queen bee. Now, I'm not saying that I'm the queen bee, but I do think that it's very important that we all work together to achieve our goals. And, that's why we have wonderful honey, and it comes in all different colors and flavors and tastes from all over the world. So in terms of the organizations or the people who funded my research, here's a little brief overview of them, just using some of their logos. So you have the Science Foundation Ireland, National Science Foundation in the US, Siemens Gamesa, EPSRC, EPA, SSE, the European Union, Department for Economy in Northern Ireland, CASE, which is a research centre in Northern Ireland, some Newton Fund money, the Department of Environment, Climate Change and Communication in the Republic of Ireland, the British Council, the Environmental Protection Agency in the Republic of Ireland, Patronus, and then EPSRC in the UK. So these are some of my team over the last year or two who've, the last few years. Some are moving on, some are finished out, and that's what I've spent the last few months doing, finishing out students and postdocs as I move from Manchester, or from Queen's to Manchester. So in terms of my own research and what I do what I'm known for really is techno-economic analysis. And what I bring to it is 15 years of industrial experience. So my own work really, it's informed a lot by my background and history of half my career being in industry. And so that brings in my undergraduate degrees in civil engineering. So that brings in the sort of, and civil engineers tend to spend a lot of their time dealing with the public, specifically if they are dealing with projects that impact the built environment or the public landscape in general. And that's why I tend to, look at the economics, I look at the engineering, and then I look at how does this affect people before it happens, while it's happening, and after it happens. So that's sort of what flavors and colors my research. And then I like to do literature reviews, and I think it's really, really important before you start to do anything, or any piece of analysis work or any type of review, any type of research work, you would do a state-of-the-art literature review. Because what I think tends to happen in academia, and this is just my own personal opinion, academics, when they're doing their PhD or a piece of postdoc work, they focus very much on one type of technology or one type of analysis or one type of approach. And it becomes almost like a religion. It's very obsessive compulsive, and they hate to see it failing, and they can push and push and push even when it's not successful. And I suppose from my time in industry, 15 years in industry, what tends to happen in industry is that when technology isn't successful and it doesn't scale, in my opinion, within 3 to 7 years, then it's time to think about whether it's the right technology or not. And that's why when I do desktop studies, so this is just a desktop study here, I'm looking at retail electricity markets, I try to figure out what are the patterns, what are the themes, and it really focuses the mind, and it highlights issues and challenges straight away. So I tend to do a strengths, weaknesses, opportunities, and threats analysis. In terms then of the sort of approaches I take, I use lots of different modelling approaches. So I can use models that are proprietary software, or I can use, first principle models where I either use code, or my group uses code, so Python or C, Jump, all different types of software, all different types of approaches for different statistical analysis, power systems modeling, so DIG silent, dig silent, we're going to come on to more of them in a minute, over different time horizons. So it depends on what I'm researching. So whatever the research question is, it might be looked at in a different way, in a different time slice. So it could be years, it could be months, it could be seconds, it could be milliseconds, it could be hours. And it depends on what I'm doing and what's the aim of the research, because there's lots of different models and they do lots and lots of different things. So you need to know what you're doing. And again, I look at them at different scales and different sectors, and using different vectors. It depends on what I want to do. So here, just to give you an idea of some of the tools I use. So I use Quintel, I use Dig Silent, I use PSS, Energy Plus, Autodesk. Plex is what I mostly use. I've used other software as well to look at power and gas systems. So there are some of the software. So just to give you an idea or a flavour of sort of some of the research projects that I've done recently with my group. So here we're looking, this was a project funded by the Department for Economy in Northern Ireland, where we were doing, where we're actually in the process of doing a cost benefit analysis for net zero, looking at heat, power and transport and the interlinks. But the difference between this and sort of other approaches is we're using Quintel, which is one type of high level model, which is what they're using in Northern Ireland, the government, in terms of its policy, or the policy makers. And then we're cross-referencing it and validating it against another model at the same resolution called Energy Plan, but to give the inputs to see the impact on wholesale energy or electricity markets and gas markets, we're using Plexus for power systems. And then some of the outputs from that, we're putting them into a social cost-benefit analysis. But again, as part of that, what we did, or what we're doing, we actually did it. We have a paper coming out on it soon. I'm going to come on to it in a minute. We did a pew and a survey of key stakeholders in terms of what they classify as important and how they'd rank and rate different technologies to inform this policy making. Another piece of work then was looking at the Northern Ireland wastewater treatment system. Northern Ireland Water is actually one of the largest electricity users in Northern Ireland. It was 2.76 of total demand, electrical demand. These are basically wastewater treatment plants in Northern Ireland, and as part of their decarbonisation pathway and plan moving forward, aeration in wastewater treatment is where you inject oxygen, or you push oxygen through the wastewater in the tanks to get the oxidation and redox reactions going, so you can clean the water and strip out any contaminants and bacteria and any nasties in it. And that's very, very energy intensive, and that's why they have such a high electrical demand. But as part of that, to decarbonise, they need to look at other alternative revenue streams. So we looked at, part of this was bringing in electrolyzers and producing some hydrogen where we could generate electricity, or we could use it for other purposes like transport activities. So that was done for Northern Ireland Water. We have a paper on that. So this is about stakeholder engagement here. So when I do the work, you know, really, I say techno-economic, but what it actually is it's socio, enviro-economic. It's covering all aspects, you know, because you really need to understand the public, the OEMs, the equipment providers. I'm not a designer of widgets. I'm not that type of academic. What I do is I take technology and I look at it where it is, where I think it's going to be, based on very precise interviews with experts. So this is Northern Ireland experts in a particular topic, looking at different, you can see here, looking at district heat networks, looking at where they see technology going into the future. And, you know, some of the results of this, which were interesting and they're probably relevant, is that carbon capture, utilisation and storage for Northern Ireland had the lowest score in terms of people's positivity towards it and thinking that it would work. And the highest score in terms of heating was insulation. So people felt that, and these are, you know, experts in the field who are, you know, they're working in Northern Ireland and they're delivering, they're developers, they're people who are selling technology, or they're policymakers. And what tends to happen is when they're in a room together, and it's Chatham House rules, so whatever happens in the discussion stays in the room, they tend to be more honest and direct, whereas they have to be diplomatic when they're dealing with certain groups or certain organisations, or they feel they must agree with policy, even though behind the scenes they probably disagree with it, or they feel things could be done in a better way. So this is another piece of work that I'm doing with another person in one of the researchers in my group. This is sponsored by the Treasury. And what we're trying to do here is identify who is suffering as a result of the increases in energy at the moment. So this is heating and electricity, and we used NASA data, Google Earth Engine, to identify homes that were that are affected by, in essence, energy poverty issues. And what tends to happen is most people who work in this field, they always assume people who will be affected are those who are on social welfare payments, are on, you know, the lower incomes. Whereas actually there's a lot of people in the middle income group who go unrecognised, who have underlying health conditions, are they're holding down a job, but they have other issues going on in their life, health issues, other health issues, or alternatively, their salary, a good proportion of their salary is dedicated to their transport, heating and electricity, up to 30 or 40% in case of the average industrial wage. And that really affects them, and they get no supports. So it's, how do we support those people? Because these are the type of people who actually can't afford, you know, even with a government subsidy for an electric heat pump or for an electric vehicle, they fall between the stools, and they're very, very important people in society. And then this is another piece of work here where we're looking at heat networks in Northern Ireland, and it's a case study of Belfast. And again, we're using plexus here and developing out a gas. So it's, you know, whatever way we move into the future, whatever way we decarbonise, things are going to be slower. And that's based on my 15 years experience of what policy ever says. Policy targets are there for us to sort of, as a goal. It's like studying for an exam. You're never going to get everything 100% done, but you might get 70% of it done. And that's why we have to set ourselves targets. So this is just, and we looked at the building stock in Belfast, weather data, U values, the end user type, so the type of customer, and the building type. And then, you know, what type of pipe characteristics for the network, thermal losses, transients, and heat plant requirements and fuel costs. So this is another aspect of my work. So as I said, I model on all different timescales from really in-depth detail of a technology and how we can analyze it to sort of the helicopter, from the satellite to the helicopter to the little widget. And in this case here now, what we're looking at is data centers and looking at data center controllers and how, you know, we can use the backup generation and the UPS, the uninterruptible power supplies in the data centers and other, because they also have batteries, because what happens is they tend to have batteries for a few milliseconds to come online if there is an issue. When their diesel gensets are their gas, in the case of some data centers, their own on-site gas generators kick in. So the reason I was looking at this was last year and the year before, as I saw the issues unfold in the Ukraine, gas prices went up across Europe. And obviously the UK and Ireland has some of the highest retail electricity prices for commercial and industrial and domestic users. And of course, you know, we also ran into auction issues, both in the BETA, which is the British Electricity Trading and Tariff Arrangement, and the single electricity market on the island of Ireland. Our prices tend to map each other on the wholesale, but our retail prices are amongst the most expensive. But what makes it really, really interesting between the UK and the GB market particularly, and the Republic of Ireland market, is that the measures that the government take are quite different. So are quite targeted. So there was a price cap introduced in GB on the BETA, whereas in the Republic, it was more a support payment into your bill. So it was a different type of approach. And those approaches, it's good to model them because our prices are almost similar. And it's nice to see how people behave. And it's all about user engagement, efficiency. How do we get people to change? And then here, what I was trying to achieve was I was trying to nudge quietly the data center operators and the regulator in the Republic of Ireland to use the backup generation, which is predominantly in the Greater Dublin area, to support grid services and grid activity. They did have some conversations afterwards, but you know, how that develops, I'm obviously not party to that, but this was the reason for that, was to sort of nudge them along and to say it could be done. So again, there's going to be a little break in my presentation here. And as I said now, honey, like the energy system, it comes in all different flavors, colors, and that's what's so lovely about it. And, you know, honey also reflects, and bees also reflect, and butterflies, the quality of our environment. So when you don't have bees and you can't pollinate, you have a problem. And that's also reflective of extreme weather and climate events where it's either too wet, too cold, or too warm. And that affects our crops, and that will affect pollination and our healthy environment. So a lot of people around the world know me, and you know, aside from my research, is in relation to my work on the journal Renewable and Sustainable Energy Reviews. I first started working in the journal, I think, as a handling editor, or as an editor back in around, I think, 2013. And then in 2015, I became co-editor-in-chief, or acting co-editor-in-chief, while Larry Komersky, who was the founder of the journal, he stepped down. And then I became, I think, editor-in-chief in 2016, 17 maybe. And more recently, then we're restructuring the journal again, and I've become executive managing editor, or managing executive editor. So I have a team of people then who report into me. They're in essence co-editor-in-chiefs. And then we have a number. So we have about maybe 15 people in the team now all over the world who work with me, making editorial decisions. I usually tend to see all the papers. They either come into me and I divvy them out, or they come in, they go out, and then they come back to me. So there's some sort of sanity check. Now, over the last few months, when I was working from Queens to Manchester, and I was minding, I had both my parents passed away over a 12-week period, and I was minding them. Some of my colleagues stepped in and had to make decisions when I was unable to do so, because we do get a lot of submissions to the journal. So just to put the journal in context, it would be up there. It's I think 9th or 7th in the area of which its comparators, which would be Nature Energy, would be above it. and Progress in Energy and Combustion would be above it. And then other comparable journals would be Applied Energy, Renewable Energy, Energy. So it's the highest site score of those journals, except for obviously Progress in Energy and Combustion, which is a very different journal. And the impact factor, I think it's up at around maybe 15 point something or 16 at the moment. But my aim or my plan, hopefully into the future, in the next 3 years, would be to get it maybe up around the 20. People underestimate the amount of work that actually goes into the journal, and I tend to do it on my own time when my children or my husband are otherwise preoccupied with their sports or their hobbies, or you know, I juggle it in around my own time. So it's very labor and time intensive, and people sort of forget that when they have a journal paper published, that they really need to review as well. So if I've any young researchers out there or any academics, I'd actually really stress that reviewing is very, very important. And even if you just review, if you get a paper published and you review maybe 4 or 5 papers in that year, it's nice and it's contributing back to the field. And it's a quality review. It's not a copy and paste exercise. So the things I like people to check is the limitations of the study, check the figures, the diagrams, the units. It's really not about putting in your own references or bumping up your own citations. That's not what it's about. It's about checking the robustness, checking the policy, seeing is there any way that you could help this academic who's your colleague somewhere else in the world to improve the quality of their work so it can make more impact, or it can reach out to industry or other policy makers to support decision making and the net zero transition. So here again, we have the B. So what I'm going to talk about here now is it's this initiative that I've started up with 2 colleagues of mine, actually, Benjamin Sovakal, who was formerly in Sussex in our house, who's now in the States in Boston University, and with another colleague of mine, Raphael Heffron, who's in the University of Pau with CNRS, which is the research agency in France. He's a professor there. He's a lawyer, okay? I'm an engineer. So I said already, my undergrad degree is in civil and environmental engineering. My master's was in transportation engineering. And my PhD really more or less is in electrical engineering. It's in power systems. So Benjamin then is a social scientist. He's very well respected and known in the field. So we're trying to get this initiative going where we can bring more skills to the discipline and to the energy area in general. Because what's happening is in industry, they're firefighting all the time. So I spent 15 years in industry, and it's like policy. So if you're working in a local authority, you're dealing with filling a pothole, clearing a drain. But if you're working, nationally in government, you're making a decision on how much money does that local authority need into the future, or how many cycleways do they need, or how many bus stops do they need, or how do we help people with their green spaces, or how do we get these renewable sites in terms of wind farms or solar PV farms or rooftop solar. How do we achieve our net zero through all the different sectors and vectors at a national level, whereas in the local authorities and sort of local government, it's really they're firefighting. So it's very, very hard for them to sort of, and people can be a bit disrespectful and a bit aggressive. And I often see it in the Twitter, and I've been mauled on Twitter. I'm very serious on LinkedIn, but I tend to be more glib on Twitter. So what I say to people is, I've dealt with local authorities, I've worked in a local authority, and it can be very problematic because you mightn't have the money, you mightn't have the resources, you mightn't have the skill set. So it's to try and get people these skills, and it's the same in industry. So we all know where we're going to end up going here is we're going to end up with higher residual emissions. So needing more reduction beyond 2060, 2050. I think we're going to end up, if you look at this graph here, it's the third one on the left. I'm hopeful and I'm optimistic we won't be as bad as delayed cuts require the most of CO2 removal. I don't think we're going to achieve either of the top 2. I think we'll be down in the bottom left. So just in terms of global policy drivers and emissions and where we're going at the moment, my work now is really, and where it's going to be focusing over the next few years, is virtual footprints of services and products in scope 3 emissions. So, and across sectors. So from agri-food, transport. So when I mean transport, I mean aviation, and I mean freight and logistics and shipping. And I mean ICT services, cement, any of those were products. So it's products and services, because really the electrical engineering in the power system is the easiest nut to crack. My own opinion is that we're not going to be this massive electrification or 100% renewable electrification of the energy system. I think it will be very, very problematic. And somebody who worked, you know, designing overhead power lines and substations and going out then and wayleaving the public and trying getting overhead power lines up, I think it's very problematic. And I don't think it will be cost effective. And I don't think we'll be able to socialize it into the future. And for us, really, we're an OECD country, so we're a developed country. In my mind, most of China is developed. India is less developed, but we're 1 billion people in Europe and our part of the world, I suppose, the global north. But the global south is where most of energy demand is going to be into the future, and non-OECD countries. So in terms of that, that's now my work is sort of going to reach more out internationally. I still do national work or European work, but really most of my work now moving forward. And that's sort of, I spoke last week at the United Nations Asia Pan-Pacific conference on it's their annual energy forum, and it was wonderful. It was lovely to meet everybody, and we had some honest discussion and debate. But moving forward, I think, you know, my own opinion is we've done enough climate change reports. COP is great, but really at this stage, I sort of query the relevance of COP in terms of everybody meeting physically in one location. I think, you know, politicians are leading it, and some of the climate change report writers, it's great for them to get together, but I think, you know, its relevance now moving forward. I think really my point at this stage is it's a call for action, as opposed for a call from more discussion and a negotiation, because really, whether it's 5 or 10% of a difference in terms of local emissions, we're way beyond that now at this stage. We really need bigger decision making and more global actions for scope 3 emissions. So coming from where we're coming from, COVID was obviously just a sort of a flavour of us, and it was nice for some people. A lot of people in our part of the world, the global north, we were able to stay at home. Our salaries were supported, but in other parts of the world, they weren't, and we're sort of forgetting that. They had no income, their food, their heating, over that period where factories, etc., were closed down. They don't have huge health resources and education resources and tools, and we've sort of forgotten. We might have forgotten that while we all comfortably work from home in some parts of Europe and North America. So to me, at the moment, we're really gambling. It's like we're in Vegas, and we're all tasting the buffet and getting the free cocktails and drinks, and we're gambling at a rate of knots. So we're locked in to carbon. We've a huge gap. It's 1.6 trillion. It's probably closer to $2 trillion at the moment. And really, that's going back to Paris. And this was estimated by the carbon tracker guys. You know, really now at this stage, the big multinationals need to get on board, especially for scope 3 emissions. Otherwise, you know, we might as well forget it. What really sort of bugs me as somebody who came from industry is when I hear people who've never really been in industry or understand what industry needs to do in terms of paying people salaries, providing a service, meeting environmental regulations or local licensing requirements. These are all the things they have to do. People seem to think that, you know, it is the bottom line and they have to pay money because they have to pay the bills of running the entity. Some climate activists think that industrialists don't care. Actually, they do, because if they don't care, they won't have customers or consumers in the future. And thinking that, you know, they're not thinking long-term about their company, and they want, you know, I worked for Siemens. They're over 100 years old now at this stage. They want to be around in another 100 years. I presume Bill Gates wants Microsoft to be around in another 100 years. So you know, it's bad for business if they don't achieve their climate change and climate targets in their own entities. So I suppose some of the things that I'm concerned about would be carbon capture and storage. You know, in Norway, they had a huge project on it. We've seen projects in other parts of the world, like in Australia, where there was a lot of investment. It didn't deliver. Carbon capture storage, you know, from my own perspective, injecting carbon into old defunct mines or salt mines or different geological features. To me, somebody who worked in industry and as somebody who did environmental planning applications and licensing, it's an underwriting issue and it's a high risk. And if anything goes wrong, it can go badly wrong. And we've already seen it with pharmaceutical companies, you know, and we'll see it with other companies where, say, in the electrical system, chlorine now is going to be banned. Certain types of aerosols and certain types of materials that are used in different industrial processes into the future, they're going to be banned, and they've caused massive environmental pollution, and we can already see class acts. So this is why I would be a little bit cynical about carbon capture and storage. Carbon capture, storage and utilisation for certain types of activities for the last mile, I think will be feasible, just like hydrogen. I have a certain level of cynicism about hydrogen, but that's my job as an engineer. You know, a civic-minded citizen, really, you know, I'm not like, I take things with a good viewpoint, but I always have to ask questions. Now, to some people that can come across as being a bit negative, but, you know, unless you ask the right questions and you annoy people asking them questions, you're never going to get to the root of whether this will work or not. The other thing I'm a bit concerned about is this mass ICT or digitization of everything. And I alluded to it earlier on in relation to electrification. You know, I always say, if you're handling something 3 or 4 or 5 times in terms of energy, you're making it from one energy type or one fuel type or one vector or one sector into something else. You know, the more you handle something, the more equipment you need, the more cost you need. And we're talking about a just transition. So, you know, to me, I like a button where you can simply switch it on and off and things work. You know, when you leave, people make a lot of decisions who aren't used to technology. And you must remember, a lot of people out there aren't as technology astute. And I say, like, old people, elderly people, you know, and banking online, you know, that's something that I think is an issue for society. So where people can't have a face-to-face meeting or, you know, go into a shop or everything is online, I am concerned about that for the future, because really automation will do away with employment and we'll wonder where we are in another 100 years.
Hi,
So,
is it possible?
I have to finish. Yeah. So in terms
30
of climate
seconds. Thank you.
Oh, sorry. So in
Thank
terms of climate change and the UK conference, I think really this sort of come by all around a candle, hoping for the best. We need to move along. We're at a crossroads. We've lots of technologies, but really some technologies, and we hear people talking about them still, which is like nuclear modular. You know, there's 60, 70 years. It's come from the nuclear submarine industry. There's 60, 70 years of research in that area, hasn't scaled up. Wave energy, and I know colleagues research it, it hasn't scaled up. You know, we talk about ammonia in shipping. Ammonia is highly toxic. It's highly dangerous in certain environments. Again, it'll be an underwriting issue. One thing that I'd like to highlight here, and I borrow it from Bill Gates, and I mentioned him earlier on, if we are really interested in changing, and if industry is interested in changing, you know, we see people now living until they're 90 odd, and it's an issue. You know, the pharmaceutical sector, they've the highest investment of any R&D as a percentage of sales. If you look at the energy sector and automotive, they're the lowest. So if we're really genuinely interested in making inroads in carbon emissions and changing our environment and protecting ourselves against climate change, then this needs to change, you know. So the problem is for governments is the tax take and the emissions. How do we find this happy balance? So when we talk about electric vehicles, how will we make up that revenue that we will lose from VAT and excise duty on liquid fuels? In terms of finance, again, I'm just referring here to Larry Fink and BlackRock. You know, he's going to have to make a lot of decisions into the future. Recently, Apple announced that it's going to be 100% renewable. Me, I'm a little bit cynical about that because, you know, moving emissions around the planet to suit yourself is something that I'm not comfortable with. So it's all about being a responsible investor. So the honey, so I just want to briefly talk about this activity here, which is the education one. And so it's hopefully now we're going to get a web page up and running on it at the University of Manchester. Here with the other collaborators, and we've spoken to other universities around the world. It's not like the MIT Energy Initiative, which is mostly oil and gas companies. This will be a good mix of Scope 3 type service providers and products suppliers. So we've the European Law Association. We obviously have the petroleum engineers because it feeds into a lot of what these organizations do. Ford Foundation, Oxfam, and the development banks. So basically, I just want to end on, really, you have to be passionate about energy and climate change and the environment. And they're my passions. You know, money isn't my driver, our salaries or anything like that. This is really my passion. And it has always been my passion since Chernobyl and when I was in high school or secondary school in Ireland, and justice and peace movements and things like that. So I really think that, you know, financial markets now need to step up, and that's where that gap is. So just as a conclusion here, this is my email, if anybody wants to pop me an email, and just so people know, and I just put it out there, I actually don't live in Manchester. I live in Cork in the Republic of Ireland for personal reasons with my children and my family. I'm a female, you know, and I can't be moving my husband around, and that's just the way things are. I try and minimize my travel. I do, you know, and my research, my actual research group, they actually live everywhere. So we meet online and we meet together every now and again, and I optimize my travel to minimize my emissions. And in actuality, I keep a track of my emissions, and my emissions actually are lower than the average EU emissions. So just to let people know. Okay, so there you are. Thank you very much for your patience as I rambled on and ranted over. Thank you.
So thank you, Professor Foley, for taking us through on a journey through your interests and your research. There's a few technical questions in the chat and a few questions asking your opinion. So please have a look and reply to them. I'll just highlight one of them, maybe to answer now, from Paddy, who's basically said, are there any similarities between Northern Ireland and the Northwest / Manchester, which you could take advantage of?
Yeah, actually, that's a really good question. There are, okay. Now, obviously, it's much larger scale. Like, I mean, Manchester is rocking. It really is a rocking city. It's like being in London, you know, and I love it. I love that buzz. And it's great being in the town centre in Queens. But it has its certain focus of certain types of activities, commercial activities, localised industrial activities that it's known for. The big difference between Northern Ireland and the northwest of England is Northern Ireland actually has very limited public transport. So Northern Ireland is amongst the most destitute. Actually, in Western Europe, Northern Ireland is the poorest area. It has some of the poorest statistics in terms of energy poverty. It has the highest penetration of pay-as-you-go meters. It wouldn't be as high as the northwest of England even. But public transport, again, international access to aviation, tie-ins to other parts of the world, the northwest of England would be better than Northern Ireland. So in terms of the parallels, there's more onshore wind in Northern Ireland than there is in the northwest of England, which is one of my grudges at the moment. And I think I'm well known for what I just think it's madness to pay more for offshore. And I think that politicians, and I was in the House of Commons and the House of Lords at a dinner on Tuesday night, and I pointed out, you know, to a number of people I spoke to, offshore wind is great, but when you have an onshore resource that you can access and service and is more secure than offshore, and considering what's going on in the Baltic at the moment, we need to think of all of these things, and we need to be more pragmatic, and we need to avoid having all our eggs in one basket. So we're hooked on natural gas in the UK and Ireland. You know, we need to get our electric heat pumps in. We need to get this rooftop solar in. But if the more rooftop solar we put on, are in, people forget that that will affect the wholesale electricity market. And you're basically pulling out maybe 20 or 30% of demand, which will then have a spillover effect into commercial and industrial retail electricity prices, which will affect the cost of living. So here is in the balance, but the regulator, both in the Republic of Ireland and in the UK, in GB, the GB market, haven't looked at it.
Thank you. Well, thank you for that. And please take a look at the chats. There's some of the questions for you to follow up on.
Okay, just 2 seconds now.
Thank you, Professor Foley. And I'll introduce our second guest, Dr. Robin Preece. And Dr. Robin Preece is a leader in future power systems, and he's also the Deputy Director of the Supergen Energy Networks Impact Hub. And over to you, Robin. You're going to talk about Supergen Energy Networks Impact Hub.
Yep, thanks very much. Can you hear me okay?
Perfectly, yes.
Perfect. Brilliant. So this will be a bit of a whistle-stop tour, I think, because we're running a little short on time. So yeah, as has been said, I'm Robin Preece. I work at the University of Manchester. I've basically been at Manchester forever. I spent some time working for a few other companies, and then decided that the university was the place for me. So Aoife's teed this up nicely by saying that the electrical energy part is the easy bit, and now I'm going to tell you that that's actually quite a hard bit too. And so the Supergen Energy Networks Hub is focused on, it's a research project funded by EPSRC, and it basically tries to drive forward research associated with the energy networks part. There's lots of other research hubs and things like this dedicated towards what's connected into the network and what's connected on the other side, drawing power. We're really focused pretty primarily on the networks and the network operation itself. So obviously when we talk about power systems, we use nice big, nice evocative emotional pictures of like pylons at sunset. But the truth is that we actually spend a lot more of our time sat behind computers doing a lot of computer modeling. Aoife mentioned as well, a lot of this is model driven research. There is obviously stuff which is experimental, but mainly kind of we're looking at large computational models that we work on. I want to describe a little bit of the challenge facing power systems. So first bit of audience engagement. Can you tell me who these people are? So who's the person on the left? Who's the person on the right? And normally you can type that into the chat. Normally my kind of audience when I'm talking will probably know who the person on the left is and will struggle a little bit more with who the person on the right is. Both born, yep, so we've got Tesla on the left. Thanks, Paddy. So Tesla on the left, born kind of, he was born 1856. They're both born around the 1850s. I'll just give you a couple more seconds to see if anyone knows who's on the right. Nope. Okay, so Alexander Graham Bell on the right. So essentially we've got kind of the father of, yeah, there you go. Aoife got in just after I said it, but I'm sure she started typing before. We've got Tesla, who essentially invented AC electrical power systems. I won't start that debate. And we've got Alexander Graham Bell, who invented the telephone. Again, not going to debate those things. The main point being that if we dropped Tesla into a modern power system today, he'd have a pretty good understanding of how that power system is working. If you showed Alexander Graham Bell a modern telephony system, modern communication systems, which have all now completely essentially digitized, it would be very difficult for him to be able to explain how that stuff's working. And what's happening is the power system is essentially going through a little bit of that kind of technological revolution right now. We're using a lot more large-scale electronics compared to electrical machines, and that's introducing new challenges in how we operate power systems. So we've got that going on as one thing. We've got another thing going on. Now, this is obviously UK specific, but what we can see is essentially this big chunk at the top. This is showing the electricity production as a percentage by source. And what we've seen is over the last 30 odd years, coal's basically disappeared to zero. Gas has roughly stayed the same since we've had the kind of dash for gas. And whoops. But what we've got is we've got this growth in the section at the top, so large amounts of renewables. And now we're at the stage where renewables make up more than 25% of our energy, a lot more. And sometimes they're producing 50-60% of our electricity at any moment in time. And in other countries, even higher as well. Ireland has gone, I think, above 80-85% wind generation at some points. So that's going on, change in generation mix. Next part of audience participation. What do we think? So each Google search uses some energy. If I, instead of using that energy to search Google, instead try to use it to power a light bulb, how long would that light bulb last? Would it be just a few seconds, a few minutes, a few hours? You can all place your guesses now. And this is essentially to try and show some of the costs. So 0.5 seconds. I'll just make it clear. I am using a kind of energy efficient light bulb. Five unitless things. So 2 minutes is much closer. The actual truth is about 6 minutes. That's assuming I've got a very low power, like a 3-watt LED bulb, but that's okay. That would be a kind of 40-watt equivalent in the old days. And so what that means is if we look at how much the entire Google searches every year, how much energy they use, well, they use the same energy as Iceland. So if Google as itself is essentially using as much energy as Iceland, the whole country, that's 73 on the list of countries. And there's about 1 million people, maybe about 1 million people in Iceland. I'm not too sure, maybe a few less. If we look at EVs, the stats I found, and again, you can argue with these stats, said there's about 26 million EVs. That's about equivalent in terms of energy usage to Greece. Okay, so there's a whole reasonable sized country represented by EVs. But then if we look at EVs right now, that's about, I worked it out as about 1.8% of kind of of cars are EVs, which means there's 98.2% of cars which aren't EVs, and obviously a decent chunk of those are going to become EVs. Even just for the UK context, that number isn't much higher. It's only about 2.7% of UK cars are currently electric vehicles in comparison. So there's a long way to go in terms of electrifying that. And if we talk about that, that's a lot of electricity we need. So if we think of the electricity network as essentially being one grid, what we currently have, the amount of electricity we use, we need one grid, our electricity grid, to be able to move that energy around, that electrical energy. If we electrify transport, that's going to need about another 2 grids in order to be able to move that around. And if we then try and electrify domestic gas for heating as well, that's another couple of grids on top of it as well. And so what you see when you see the numbers is that the kind of electrical throughput, which is expected of the future system, if we massively electrify these different sectors, if we electrify transport and if we electrify essentially heating, that means we're going to need 4 to 5 times as much energy going through the electrical network. And that means obviously that's a lot more electricity than we're currently used to and than the current grid can cope with. And that's why if you start Googling it, you start finding all these headlines. UK electricity network faces mind-boggling scale of change. National Grid sets out case for urgent reform to drive energy transmission, fundamental step change, largest overhaul of the grid in generations. I think one of the quotes or one of the statistics was that National Grid said that they would have to build, I think, 6 or 7 times as much energy infrastructure by 2030, so in the next 7 years, than they've built in the last 30 years. So in the next 6 or 7 years, they've got to build 6 times as much than they did in the last 30. Now, albeit the last 30 was a period since liberalization, whatever, where it was fairly stagnant for growth, and our electricity consumption has been fairly stable as well. It's not increased massively. And so there's not been a huge incentive to build a lot, but this is not a company with supply chains which is set up to be able to deliver that level of transformational investment into the networks. So it's a huge challenge, massive challenge. Then we've got all these new sources of generation. So we've got turbines, which are obviously spinning if it's windy. We've got solar cells, which are producing electricity if it's sunny. But you can see here, there's a cloud transiently passing over the top, causing that energy to dip for a bit and then come back up. So that means we've got variable, uncontrollable generation, and that's a challenge for us to deal with. So the way we operate our system is we let all the various generators say, how much power do you want to sell to us? And we say, okay, they place their bids and we buy it and we say, thanks very much. But then obviously they might not actually be able to produce that. If the wind isn't there, they can't do it. And so what happens is at the last minute, the system operator has to step in and balance things out, and they have to pay to do that. So they have to pay some people to generate a bit more, some people to generate a bit less to keep the system balanced. And that's getting more and more expensive. So it's gone from being just 3 years ago or 4 years ago being about £1 billion a year to balance out this cost. Last year it was 4 billion, and it's just going up and up. And this is because this amount of variable, uncontrollable stuff, which is on our network, keeping the system operating is getting more and more expensive. And obviously that cost is a major issue. This is something that then needs to be fairly and justly shared out around everyone. Not everyone can afford to pay the same stuff. Should this all just go into electricity bills? Is that a fair way to do it? Should it be kind of subsidized and come out of taxes and things like that and be essentially paid for by the government? Is that a better way to do it? Those are questions that I'll let people like Aoife answer and other people on the hub answer. I myself like to stick with a pretty hardcore just mathematical modeling of systems instead, because I find as soon as there's pound signs, I tend to find it gets a little bit complicated. So that's going to bring us on to the Supergen Energy Networks Hub. I'll give you hopefully that's given a brief overview of the kind of scale of challenge facing energy networks. And what the point of the hub is. So it's this 5-year research project, and it kind of has two aims. On one side, its aim is to, within the hub itself and within the researchers who work within the hub, to carry out highly impactful interdisciplinary research to try and make energy networks not just these passive enablers of low carbon transition. So not just seen as this kind of thing, well, it shouldn't be a block, it shouldn't get in the way, it shouldn't stop people doing things, but actually try and actually make it into a driving force, try and make the actual network itself something that helps accelerate a kind of rapid, safe, just transition to net zero. And that's from the research perspective, but also it's doing this other job, which is just trying to bring together the vibrant, diverse energy networks community. So it has a role as well in terms of putting on events, putting on different things, workshops, training for early career researchers, all that kind of stuff, trying to help bring the community together so that it's not just little pockets of research all working in isolation, but it's a bit more coherent and working towards one goal, as Aoife again was saying. In terms of the actual research itself, we're kind of divided in different ways. So within the hub, some of us work on different things. I myself work in this kind of risk and resilience area. So I do a lot of statistical modeling of systems and try and understand how they fall over, what makes them black out, that kind of thing. And there's other people working with us on that. We also have kind of these strands related to markets and regulation, policy, society, and place as well. So regional energy networks are a very important thing as well, and often provide a lot more scope for kind of innovation at a very local level that can be driven forward by local politics quite often a bit more easily than it can at a national scale. And also digitalization. And here we're talking about digitalization of the network itself. So obviously not turning the electricity into ones and zeros, but the monitoring of our system. We get so much more data about our network now than we ever used to. And can we use that to operate it more effectively, more efficiently, to be able to make it more secure as well? And then across that, we have these various different missions, which are kind of cross-cutting ideas. So these are things related to the whole system, so kind of across multiple energy vectors, looking at large-scale networks at the kind of national transmission level and also these regional ones. And how do these then draw from the various different kind of pillars of digitalization, risk resilience, etc. In terms of skills, we have a huge number of skills. This is just what's within the project, and this is starting to kind of showcase the wide range of skills we need to bring together in order to solve these problems. So things from obviously markets, risk modeling, heating and cooling, flexibility optimization, decision making, quantitative human geography as well. So where are the people? What are they doing? How are they moving? How does that affect energy usage? So hopefully some of you as well might recognize some of your own skills within this list, or might think, oh, I've got other skills that I could help bring to this as well. In terms of partners that we're working with on the hub, so this is the list of essentially everybody who gave us a letter of support when we submitted this to EPSRC, but it goes across a wide range. We've got university kind of projects, so HIACT is on here, which Aoife is part of, but different things. EDRC is the Energy Demand Research Centre, UKIRC, RITIX is about kind of digital, safe, trusted infrastructure and like cyber modeling. So lots of different things. We've got loads of the different utilities, so National Grid, SPEN, National Grid, gas networks as well, Wales and West. We've got technology providers, so people like Siemens, Krakenflex, which is like the technology wing of Octopus, government and third sector, so some local things, but also Department for Economy from Northern Ireland, BEIS, DESNZ. So national and local level, and then some consultants as well are all interested in what it is we're doing and whether we can turn some of that into solutions. And then quickly, I'll just go through a few things. So I'm the deputy director of the hub. It's led by Phil Taylor, used to be at Newcastle, now at the University of Bristol. So he's the one in charge. It's a 5-year project that started just about a month ago. So we've just started, we'll be running for 5 years. So hopefully you'll see more of what it is that we're doing. It's worth noting we host conferences and workshops. So some of you might have been to a Supergen Energy Networks Hub conference before. If you haven't, maybe keep an eye out and there might be an opportunity to go to one in the future. We do have a mailing list. You can, at the moment, if you email this email, you'll be able to be put on it. Or you can find the website. Our website is currently not great. And we're having a new one built, so we should find a new website soon. We also have an early career researcher committee, which is in the process and is about to be refreshed. So if you're an early career researcher and you think, you know what, I'd actually like to be part of that committee, we're going to have a call out soon to encourage people to apply, and then we'll be selecting a new committee. And then essentially you will have control over some of the events that we do, what it is that we do to help support early career researchers. And then we also have a flexible fund, not a huge flex fund, so about 500K's worth of funding, but this is stuff that we will be making calls out for as well. So inviting people to submit project ideas, and we'll be trying to support people to do their own research, which will then help towards this aim of kind of accelerating the use of or the innovation within energy networks. And while I have you, I can't go through a presentation without trying to pitch the Risk and Resilience Day. This is an event I run every year. Next year in March, it's going to be in Newcastle. The main thing to do, if you're interested, if you think, oh, I work in something related to risk research in electrical power systems, or even just energy networks in general, if you search Risk Day, you will find the website, and that will give you all the information about that. That's everything I wanted to talk about, and I think I just about made it in time.
Thank you, Robin. Thank you, Dr. Robin Preece, for that. There's some really great facts and figures in your presentation there. I've definitely learned something. There's one technical question online, which I'll leave you on the chat to leave you to answer. But just as a follow-up, if people have relevant projects which are relevant to your hub or would like to link through to it, how would you recommend they would do that?
So they can contact me. Or they can get in touch with that email that was on there on the presentation, or they can, if they search, they'll find that email by searching Supergen Energy Networks Hub. We host different events, so you can always come and find us and talk to us at those as well.
Okay, well, thank you both Aoife and Robin for being our guests today, for your great presentations, and please send through your questions and join us out in the next Sustainable Futures event. So the next one we have in the calendar coming up in December is a conference, Accelerating Just Climate Action Conference on the 12th of December. And Emily has just put in a link there to join that. If you'd like to join, please look at the Eventbrite and see whether it's for you and come along and join. There's going to be lots of great speakers. But further ado, thank you for coming today. And thank you again to our speakers. And I'll leave the window open a few moments so people can look at the chat. But yeah, thanks for joining us today.